Hi, in this video, I'm looking at how to calculate the solutions to inverse sine, cos, and tan. So inverse trig functions. Okay, and I don't mean just one solution, I mean solutions, plural. Okay, and the reason is if we have a look at, say, the graph of sine or cos, well, let's just start off with sine. Sine starts at the origin and it wiggles its way up and down, and it also goes into negative numbers. And so on this axis, we have, x, or the angle that you actually have, because this is the graph of sine x, which is really the graph of the sine of the angle to give a result. So if I know a particular answer that I want, say this up here, I know it's going to happen at this angle, but I also know that if I keep going, it's going to happen at this angle, and here, and so on, and also back here as well as my negative angles, as well as here and forever. So I've got multiple solutions, and we want to work out how do I get these multiple solutions. And it's the same if I get, say, the cosine and I graph that, it's going to do something like this and something like this. So cosine also has multiple places where it can get the same answer. And it's also the same for tan. Now, the best way to think about this is to actually look at it geometrically on our unit circles. So let's put our graph aside for now, and let's have a look at the tan of an angle giving us the result A, whatever A happens to be. Now, we know that we can get our angle by doing the inverse tan of A. And let's just pretend for now that if we go and draw our solution, we end up with the positive angle, just whatever that angle happens to be. So now I want to think about where else do I also get my other solutions? Well, we also know that tan of an angle is the value y over x. So if I think about it, it's giving me this y coordinate and this x coordinate on the unit circle. I'm not going to draw the circle in. Where else will we get the same ratio y over x? Well, if I think about taking the negative of whatever that x is and the negative of whatever that y is, that's going to give me inverse tan, giving me negative y over negative x, or tan giving me negative y over negative x, of which the negatives are going to cancel, and I'm left with y over x. So I would also get the angle down there to the same values of x and y, but just the negative versions of them. And so how do I get this one? Well, that's a whole extra pi onwards. So my first angle was theta. My second one is all the way around to here, which is going to be the angle we had plus pi. So I'm going to have pi plus my angle. But then I've got to go to the next one, which would be all the way around to here, past here, and back to our first angle. Well, that would be, well, a full rotation is 2 pi to here plus our angle. So it'd have 2 pi plus our angle. And then my next one would be all the way around to 2 pi plus an extra bit to get around to there. So it'll be all around to 2 pi plus our angle plus another pi. So I've got 3 pi's plus the angle. And this pattern would just keep on going. I would have then 4 pi, a full 2 rotations plus my angle. And then 5 pi, 2 rotations and a half plus my angle, etc., etc., etc. It would also go the other way. So I would have, say, a negative rotation around to here. So it would also be this rotation around here, but that was basically a negative of a pi, and then come back theta is the same thing. So it would be minus pi plus the angle. And then I could have go around twice 2 pi and then back. So negative 2 pi plus the angle. And this one would be 0 pi plus the angle. So that means I've got some number, lots of pi, plus my angle. And that's our solution. If I have the inverse tan of A, and I want to know what that is, my angle is going to be some number times pi plus whatever the angle is, where angle, that theta is the base solution, whatever the starting solution was for theta. And that's our answer. The only thing we've got to remember is, of course, that n must be an integer. So it must be an element of our integers. But other than that, the result of this, all the solutions are a certain number of pi's plus theta. So 1 pi, no pi's, 2 pi's, 3 pi's, negative 5 pi's, plus whatever the base angle is. Let's have a look at sine next. So if I've got the sine of the angle equals A, so I want the angle, and that's going to be the inverse sine of A. So let's have a look at this on our Cartesians, or our unit circle. And let's start off with, I've got this angle for A, which is again theta. Now, where's our next time that this occurs? Well, we know that sine theta gives us the y value. So this has got this y value here, which if I bring it across, the only other way to get that same y value is to have an angle over here. So we've got this angle over here, which this angle in here must be theta. So now I've got to think about, okay, how do I get these? Well, this angle is really the one I care about for my second angle. So it's going to be, well, we could have all the way to pi and then minus of theta. So that would be pi minus the angle. Okay, let's go all the way around. So I've got 2 pi rotations plus the angle. So that'll be my next one, 2 pi plus theta. And the one after that, what I'd have to go 2 pi rotations around plus another pi, so that's 3 pi, but then I've got to back off theta. So I'd have 3 pi minus theta. So I've got no pi's plus theta, which is no pi's is here, plus theta, a pi minus a theta, 2 pi's plus a theta, 3 pi's minus a theta, and our next one after that would be 4 pi's plus a theta. So we've got basically n pi's, but then I've got to add or subtract a theta. I've got to either sometimes add the theta or sometimes subtract the theta. But it depends on what n is. When n was 0, I've got to add. When n was 1, I've got to minus. When n was 2, I've got a plus. So I've got to actually come down to how do I write it where I'm going to add a theta or subtract a theta? Well, the trick to that is by multiplying by negative 1 to the power of n. And the reason this works is when n equals 0, our first one, we've got negative 1 to the 0, which is 1. So I would have positive 1 times by theta. When n is equal to 1, well, I'd have negative 1 to the 1, which is negative 1. So I've got negative 1 times the theta. And when we've got 2, I've got negative 1 squared, which is positive 1. So positive 1 times the theta. And then we've got negative 1 cubed, which is negative 1. So negative 1 times the theta. So it works. So that gives us our answer. Theta is going to be the inverse sine of A, which means that our angle, or all of our solutions, is however many number of pi's we've gone around, plus or minus the angle. So we're going to add on negative 1 to the n times theta, which we just write like this. So I'll just clear up that n. So that gives us our base solution for this one. And of course, n is again an integer. So our total number of solutions, our generic solution, is n pi plus negative 1 to the n thetas. Okay, let's have a look at cos, the last one we haven't done yet. So if we're going to have a look at cos of an angle equals A, meaning that our angle is the inverse cos of A, well, we're going to have a look at our unit circle and put an A, our angle here. Now, we know that cos gives us the x value of the unit circle. So really, cos is giving us this x value. So my first angle is theta. The next one's going to be wherever I can get the same x value, which would be down here to get that same x value, which means I got to come down here by theta. Now, the way to get this is really to go around the full revolution and come back a theta. So my second one is going to be 2 pi minus a theta. But the one after that is going to be do that full revolution, 2 pi, but then I've got to only add on theta to get back to there. So now I've got 2 pi plus theta. And then to go again, I've got to go around another rotation. So 2 rotations is 4 pi and back a theta. So I'm going to have 4 pi and minus a theta to back off 1. But then I've got to go all the way around 4 pi and just go forward by theta. So I've got 4 pi plus theta. This also works backwards because I've got no pi's plus theta. But remember, I can also go no pi's minus a theta. Now, the trick with this one is I've got the same pi's twice. 0 pi, 2 pi, 4 pi. So I've got n lots of 2 pi. So I've got n lots of 2 pi, so 2 pi n, and I'm adding or subtracting theta. And this is our general solution. There's no way I can compress this because for every 2 of the 2 n's, or 2 of 2 pi's, every 2 of these, I've got a plus version and a minus version, or a minus version and a plus version. So that gives us our solution. Theta is the inverse cos of whatever the value is, and the general solution is 2 times pi times n lots of 2 pi, plus a theta and minus a theta. I actually have, for every 2 pi, there's a plus theta and a minus theta. So that gives us our general solutions. The general solution to the inverse tan of a number is, well, we had n times pi plus the angle. And if we want the general solution to sine, well, inverse sine of a value, that one's going to be n times pi plus either plus or minus, we don't, depending on what n is, negative 1 to the n theta. So that gives us either plus theta or minus theta. And for cos, the inverse cos of the number is 2 times n times pi, oops, that's supposed to be an n, plus or minus theta, because they've got pairings. And they're our 3 general solutions.